Hi, I'm Zias Caravala, live here at Mobile World Congress 2023. I'm at the AWS NextLevel area, and I'm going to do a ZKTour. I'll go through, we're going to look at a whole bunch of demos and understand how AWS is actually helping telcos go through their own digital transformation. So why don't we go in, take a look around, and see all the great stuff that AWS is doing. All right, well, I'm inside the AWS NextLevel demo hall, and I'm joined by Sigit P. Alkaya.
Works for me.
Give us a quick introduction to yourself.
So my name is Sigit. I'm a senior product manager for IPW, Integrated Private Wireless on AWS. It is a new program that we just launched last week, and the goal is to collaborate with CSPs to create a joint product so we can answer enterprise customer in industry, private 5G, and analytics, and so on, right? So that's the goal of the program.
Obviously, every operator is looking to help customers with private 5G. You know, sometimes they need a little help getting these services rolled out, and you know, IPW is supposed to do that. So, what are you demoing here?
Sure. So the goal of IPW is just to make the private 5G and use cases ordering very easy for enterprise customer, right? So enterprise can go into this web page.
Wait, I thought the normal way was to have to go buy a bunch of different components and put it all together yourself.
So that's the normal way, but we're trying to make it easier, right, for our enterprise customers.
Okay.
So that's why we create this landing page with pre-validated SKUs from our partners, in this case Telefonica. So enterprise can just click it and start to consume the private wireless solution.
All right.
Let me show you how we will do it. So it's as simple as go to the portal and then you browse based on our collaborators here, which is Telefonica Tech. In this use case, we focus on two types of deployment, right? So first is full on-premises with Outpost or Snow, and second is a hybrid model where some use cases need machine learning training in the cloud and inference on-prem for low latency inference.
Got it. Yeah.
Yep. Any questions?
Yeah. So, what type of customer is ideal for this?
Actually, one very good example is manufacturing, where there's a lot of device being produced, and with this technology, we can detect defect on the product, right?
Oh.
If there is a toy with less wheel, it's supposed to be 4, but there's 3. We can put that toy into the left bin and the nice toy into the right bin.
And using camera technology for that, right?
Exactly. We have a live demo too here if you want to see.
Yeah, that'd actually be good if you could.
I think for this, I'll hand over to Gonzalo.
Yeah. Telefonica Tech is one of our partners for IPW, right? And Telefonica Tech is within the Telefonica group, is the branch that takes care about IoT and analytics, right? So they are not interested in providing just alone private 5G connectivity. They want to provide an added value service on top of it. So for them, private 5G is a vehicle to address the customer needs and provide a particular solution for a use case. So in this case, it's an industrial IoT use case. Okay. And this is a very simplistic example, right? But the architecture is fundamentally a combination of an on-prem deployment and some other services that run in the region. Why do we need this on-prem? Because the use case requires real-time computer vision detection. Low latency, ultra low latency. It has to be on-prem.
Yeah.
So it's a combination of private 5G core running inside this novel edge, a computer vision ML model that has been trained in the region where we can do the heavy lifting, but where we deploy the inference inside this novel edge, right? And then we have, in this demo, a simple IPV view stream from the camera into the computer vision inference model. The model decides, in this case, what type of Pokemon we're using. This is an example for something that would be more industrial, right? But based on that, Telefonica has developed their own Smart Hub component that is also running on-prem, that orchestrates that PLC, right? And provides the action to move in one direction or another. So basically, we correlate the computer vision classification with an action in an industrial IoT environment. Okay. That's pretty much it.
And to me, this is a perfect example of the importance of edge computing,
yeah,
right?
Of course.
Too much latency in the cloud. So.
Okay, shall we test it?
Yes.
Do you want to put the Pikachu?
Sure.
Maybe
I'll
just place it in the middle.
Okay. How's that?
That was it.
Oh.
So it's basically classifying that Pikachu needs to come in this direction.
Oh, so if
you go this direction, and you take this one, for instance,
it'll go the other way, right?
And you put it in the middle.
Oops.
It's moving in the other direction, right? right?
So it automatically recognizes it.
Yeah, so basically what happens in the background is that the camera streams the video real time to the Snowball Edge. The computer vision inference detects what type of Pokemon we are detecting, and first the result gives the result back to the MQTT bridge. The PLC orchestration component reads it and programs the conveyor belt to move in one direction.
But you can see this being used in retail, automotive. There's all kinds of use cases.
Exactly. We wanted to make it simple here for the demo, but
and a little bit fun.
There are exactly, but there are plenty of applications out there.
All right. Well, thank you for that.
Nice to meet you.
I appreciate that. Yeah. So I'm here now with Owen Law at the second station inside the AWS demo area. What are we looking at here, Owen?
So we're looking at a 5G-enabled fulfillment center solution enabled by AWS technologies and our industry partners.
So the theory here would be a totally automated fulfillment center.
So what we're showing is a realistic fulfillment center situation where robots and humans kind of work and supplement each other.
Cobots.
Yes.
Yeah.
So here we're showing two very simple workflow. The first workflow is what we call the bean-to-person robot transfer.
Okay.
These basically offload, the need for human to carry heavy items from one point to another inside fulfillment center.
Oh.
And then the second part of the workflow is what we call pick-to-light application. This is an application provided by our industry partners, Riva Plus. So they basically allow the picking staff on site to follow a very simple lighting system to make sure they pick out the right items, right quantities.
And this is a big deal. I mean, companies that don't use the right analytics for picking can have a lot of waste, right?
Yes,
So,
correct.
Yeah.
So one of the key business problems we're trying to address is the efficiency inside that fulfillment center. And that's why we use a combination of robotics and also industry applications.
So can we see it work?
Yes, of course.
Yeah.
So the first part of this is imagine customer place an order through an e-commerce portal. That order will be centrally orchestrated, and the last stage of that order is the actual fulfillment stage at the fulfillment center itself. So what you can see is the robot has been programmed to be on standby, ready for that order to be fulfilled. Our picking staff will follow the lights, so they will pick out the right quantities according to the light system. And then at the end of that picking process, we'll play a very simple music to signal that the order is complete. These robots will basically be going from the picking station to the packing station. And this is where usually we have quality control as the last step to make sure that it's the right order before we pack and ship it to the customer address. Yeah. So the robot
It's self-aware.
It's self-aware. It won't run into people, but it still needs to be centrally controlled. And that's why we're using 5G to connect this robot to the central control system deployed on AWS.
Oh, and so it's taken the...
Yep. Yeah, you need to give it a little bit more space.
Okay.
Yep, so now the robot is at the picking station.
So we're thinking about pick the stuff here.
Yep, so now that the first order is fulfilled, the second robot will be on standby, waiting for the next order to be fulfilled.
Okay.
Yep. So that's the main demo.
All right.
Yep.
I appreciate that. Thanks. All right, we're here at the smart home area of the AWS demo area. So I'm here with Hadi Caliban. Okay. Well, I'll call you Hadi. How's that?
Yeah, absolutely.
Yeah, and so give me an idea of what we're looking at, why you set this up, the concept behind it.
Yeah. Well, thanks for coming, first of all. So the idea behind setting up this environment is to show that right now the smart home market is saturated with different brands, different devices and models, that most of them only works with their own ecosystems and usually require their own application to manage. What we did as Amazon or AWS is to create technologies that give us the capability to zero touch onboard all of these devices, regardless of model, brand, and the protocol they have. And as soon as they get deployed and onboarded, they're going to also leverage another set of technology called based on ubiquitous control that provides a unified fabric and abstraction layer on top of all these devices.
Okay.
So in this case, if you have multiple devices from different brands and models,
It's not so smart, usually, right?
well, we made it a smart
Yeah,
for you. So we made, that's what we did. That's the beauty. We remove all those complexities for the end users. So now they can manage multiple devices through a single pane of glass. A good example, if you just follow me,
Sure.
is basically what we do here. What we do here is, this is a portal that has all these devices set up, and you can see and manage each one of them. As you can see here, we
That's
have
a
the
lot of
living
devices.
room. Oh yeah. So, and other than, let's do this way. As you can see, we have ring alarm here.
Yeah.
We have Hive thermostat. We have Philips Hue light. We have an inner lamp over there. We have Alexa, Siri, Google Nest. So all of these devices are smart. Lock is based on SwitchBot. Each of these different brands usually have their own application
Yeah.
to manage.
You got one of everything.
And now you can see all of them in one single place. With one single touch, you can, for instance, turn off all the lights in your living room and then bring them back on. And the beauty about the integration is that now you can leverage each one of those voice assistants in your home to manage all these devices.
So you could use Alexa for all of these.
Yeah, let me show you this.
Yeah.
Follow me, please. For instance, I would ask Alexa, Alexa, turn off all the lights. Hey Google, turn on all the lights. So now as you can see here, all the lights are now on.
Yeah.
Another good example is that now with this portal, you can see the 3D model of your house as well and the status of each of these devices.
Yeah.
And if you follow me back again here, we can show you here's the 3D model of this booth area that we built. So it just needs to take refresh. There you go.
Oh.
Here's the 3D
That's very
model.
cool.
And then we now have a view of the TV. And as you can see here, the lights are on, they're purple. The shade over there is purple. So we can also see the visualization of the device's status as well.
And so if they went off, would that change status on here?
Yes.
Oh, that would.
Yeah. So, like, you know, the door lock, everything gets set up here. As you can see, the curtains are blurred because they're open. As soon as you close them, they become solid black.
Oh.
Just to indication that
they're open.
the curtains are open or red. So now this is available for the users who want to have that visualization. They don't have to, it's an optional capability.
And where would one get that?
Pardon?
So where would a user download that from?
So this is leveraging an AWS service called AWS Twin Maker, which gives you the digital twin capability.
Yeah.
We leverage the same one because we are using our own AWS services. But yeah, if it's the portal the customer built or the service provider builds, they can leverage any digital twin technology of their choice.
All right.
Another capability is around integrating, as I said, these different vendors. For instance, here, we do have a Nest camera, the Nest doorbell. You click on this doorbell, and what happens is that if you're at home and then you have these privacy windows setting, they just go blind and then avoids these outsiders to see what's happening. Or here we have a sensor that senses any touches of the glass. That's another way that, again, this, sorry.
So touching the glass would actually,
touching the glass makes it blind, and unfortunately, there's a setting environment right now. It's crowded, but yeah, that's another way of integrating all these different technologies together. Another thing is that if someone is at the door while you're watching a TV, you can ask Alexa to do a picture-in-picture and show you the Nest camera coming up on this
TV.
A smart TV, on Amazon Fire TV actually. So this is how we can show all these different kinds of integration and arts of possible.
All right, well, Heidi, you're putting the smart in smart home.
Absolutely,
Yeah.
my pleasure. Yeah,
All right,
for sure.
thanks. Appreciate the demo.
Yeah.
So I'm here now with Samir Majumdar, and you're going to be showing here Nokia running on AWS, right? This is one of your great partners.
Absolutely. So what we're seeing here is the full Nokia Cloud RAN stack running on different components of AWS infrastructure and using different AWS cloud services, right? So to start with, we've got the Nokia DU running on an AWS server and we've got the Nokia CU running in an AWS region.
Okay.
So let's talk about why we do this, or why we even care. There's 3 pain points that AWS and Nokia together are tackling. One, we're solving the integration complexity challenge. Today, when a customer goes and builds this disaggregated solution, they have to go find a hardware partner.
Yeah.
They have to go find
It's a lot of complexity,
partner.
right?
There's so many. There's 3 or 4 partners pointing their fingers at each other. It's very difficult to solve. AWS and Nokia now are bringing a completely pre-validated, pre-tested solution to the market, so we're saving CSPs from all of that time that they would otherwise spend.
Yeah.
That's the first thing. Second thing, with the disaggregated solution, it's very hard to get carrier-grade performance. There's typically some performance trade-offs inherent to the solution itself. We're actually building the new Nokia inline acceleration SmartNIC that they're demoing in Hall 3 into our server.
Oh,
So for the first time, you're actually getting the same software, the same code base that Nokia runs in its traditional software in this type of product. So it's feature parity with traditional RAN. So there's no performance, it's carrier grade performance. And the other thing is that we brought our ARM-based Graviton 3 processor to the solution. So if we think of what 5G is, all of the high data rates, there's capacity, but CSPs are also starting to look more and more at the cost of energy as the cost of energy is rise. So it's a complete ARM-based solution also.
You know, it's funny at this show, telco transformation's been a main theme for 10 years, right? And the telcos have transformed slowly, but I know a big part of that is the complexity of trying to put all these things together. So the cloudification of it actually should help them accelerate their transformation efforts, correct?
Not only that, so not only the integration of it, but then it's everything from the deployment side of it too. And I think this is where you were going, is things like the telco network builder, that cloud service is what we're using for automation.
Yeah.
So it'll configure the software, but then all of the continuous software upgrades, the image management. As you get more and more features to get the promise of 5G, you're going to get more software, right?
Yeah.
We need to accelerate and simplify the way that you actually get those upgrades. That's what this does.
And ultimately that would lead to faster innovation cycles too for them, right? Yeah.
Faster innovation, better network, better observability. So services like CloudWatch for the infrastructure monitoring, right, giving you those real insights. And the whole point is that we're extending it across the entire network. So it's the DU, the actual server, then it's CU, it's a common cloud model across the estate. So let me just show you what's going on. Here we've got the Nokia RU that's actually connected to an AWS server with the DU with the Nokia card built in, and that's actually talking to the Nokia CU in region. So it's the end-to-end solution connected to a massive MIMO cell, and what you're seeing is the end user experience, so 1.5 gig. That's what the phone would be doing.
That's a lot of throughput.
It's a lot of
Yeah. All right. Well, appreciate it. It was great seeing how you're making telco infrastructure simple. Like I said, I know it's been a big problem for a long time, so hopefully I have some success with that.
Definitely. Thank you.
Thanks. So I'm now here at another station. I'm joined by Abhit from NEC and John from AWS. And you guys have worked together to create a disaster recovery solution for Docomo, right? So can you walk me through that?
Yeah, sure. So what we're showing here is disaster recovery on the AWS cloud. Disaster recovery, we've learned from operators, is a really compelling use case because when there's no disaster in place, when you're not using the capacity, you don't pay for it. So this is actually quite compelling to operators. They don't have idle equipment sitting around, and there's a significant cost saving versus traditional ways to do this. What we're showing here is we're showing a pilot light strategy. So the recovery time is in the tens of minutes. Actually, it's a bit shorter than that. There's a continuum of different things you can do. So if you really want to be able to transfer in real time, you can do that. It costs more money. At this point, let me hand over to Abhijit, who's going to actually demonstrate show the demo actually works.
Sure.
So hi, I'm Abhijit from NEC, and I primarily work on NEC 5G core. So let me show you the reference architecture for this demo. So here you can see we have a telco data center where we have installed, NEC has installed all the 5G core mandatory functions, and we have a DR data center where we have installed our NEC 5G core network functions on AWS Graviton processor, which is environment friendly and it is energy efficient. And in collaboration with NTT Docomo and AWS, we have achieved 72% less energy as compared to Intel x86 processors, and we have also achieved 40% less cost as compared to Intel x86 processor. So in this demo, both the data centers are connected to the G Node B. And let's say if there is any maintenance activities there, or if if that site goes down, like maybe in the disaster recovery case, maybe in the Turkey, we have earthquake. So in that scenario, the traffic will shift from telco data center to DR data center, and our 5G service continuity will be continued from the DR data center. So this demo I will show you at the AWS console as well. So this is the telco data center, which is shown there, and currently all the instances are in running state. And at the DR data center, we have stopped these instances to do the cost optimization. So whenever, and currently the traffic is running at the 5G6 telco site. Now to emulate the disaster recovery, I will stop the instances at the telco site, and I will start the instances at the DR site, and it takes less than 1 minute to shift the traffic from 5G core telco site to the DR site. So it takes 30 seconds to make Kubernetes, to make the pods up of the NEC 5G core, and it takes 30 seconds to reflect it on Grafana. So it takes around less than 1 minute to shift the traffic from 5G core telco site to DR site, and we are doing a 10K subscriber testing here. So if the subscriber count increases, in that case also, in case of millions of subscribers, in that case also we can achieve it within or less than 5 minutes. And just to add on that, we have installed our 5G core control plane on C6G and NEC user plane on C7G. On the C7G, we have achieved 40% less CPU utilization as compared to incumbent processors.
So there's a big sustainability angle there.
Yeah. So the two key features in this demo, first is the disaster recovery, where we have stopped the instances to do the cost optimization. And second key feature is the energy optimization, where we have used AWS Graviton processors. So these are the two main use cases for this demo. And maybe we can see the traffic will be shifted to the 5G core DR site. It takes few seconds to shift the traffic. So this is any questions?
Yeah. No, that was good. And I like the sustainability implications of it as well.
Yes.
It's not just disaster recovery; you're actually helping save the planet. So.
Yeah. So we have installed all the mandatory 5G core network functions on AWS. So it is supported by NEC.
All right. Well, thanks. I appreciate the time.
Thank you. Thank you so much.
Okay, well, that wraps up the ZKTour. I hope you enjoyed it. AWS is doing some good stuff out there, and hopefully we'll see the transformative telco soon. One more thing, don't forget to hit that subscribe button, and I'll see you next time on another ZKTour.